Hello, welcome to vectors. First of all, what are vectors? Vectors are quantities that we would use in physics that have both a magnitude and a direction. And we sometimes represent these with an arrow pointing in the direction of the vector, and sometimes the length of the arrow is proportional to the magnitude. This contrasts with what we would call scalar quantities that only have a magnitude and no direction. What do we mean by that? Well, here's a list of scalar quantities, here's a list of vector quantities. All these things have just a magnitude. So when we say a length, we could say 10 centimeters. We don't know which direction, doesn't matter. We could say 10 centimeters to the east, it now becomes a displacement, which is a vector quantity. Speed, 10 meters per second. 10 meters per second to the west becomes a velocity. Now, some of these quantities don't have a vector equivalent. For example, time only has a magnitude, so it doesn't have a vector equivalent. And we've use some of these: volume, mass, energy. We're going to use some of them as well. Vector quantities, they would all have a magnitude and a direction, but sometimes, just to confuse students, we don't always mention the direction in questions or when we're talking about them, because it's the direction's not important, or the context of the question is such that you don't have to give a direction. But if you're being asked about vectors, you're going to be given a direction and you're going to be expected to use a direction. So with vectors, we want to be able to add them together, and we can add them together, and when we add them together, the sum of the vectors is called the resultant. What do we mean by that? Well, here we have two people pushing a crate, applying a force of 100 newtons each. The resultant is going to be 200 newtons. Now, if this arrow represents 100 newton, what the textbook should have done is actually draw this arrow twice as long as the 100 newton one, because generally speaking, when we're trying to draw our vectors, we try and show the magnitude by the length. In the old days, you used to measure them and write scales and do it all on graph paper, but we don't really need to do that anymore. Let's move that off. Okay. Excuse me. What about this case? How do we add these two vectors? Well, we would know from personal experience is if two people pushed on a crate with the equal amount of force on both sides, the resultant is of course going to be 0. There you go. Let's do another example. In this case, a rowing boat travelling at 5 meters per second east. It's being helped by a current which is also moving to the east, but only at 1 meters per second. So you're paddling downstream, for example. Now, we would know that this would be a velocity of 6 meters per second, but how do we actually work that out? Well, we use what's called the head to tail technique, and that's where we draw a line. The resultant line is drawn from the tail of the first arrow to the head of the second arrow. So the resultant is the line drawn from the tail of the first arrow to the head of the second arrow. This is what it looks like. Here's an arrow representing the velocity of the boat. Here's an arrow representing the velocity of the river. Notice that it's smaller. Draw the first one, put the tail of the second one onto the head of the first one, and the resultant goes from here to here, was represented by this. Now, sometimes students get confused and say, well, doesn't matter which arrow I draw first? No. If you'd drawn this one first and then put this arrow or this vector there, you'd get exactly the same result. Okay, just reaffirming head to tail technique to add vectors together. Here's a couple more examples. 40 newtons to the right, 30 newtons to the right. The resultant from the tail of the first to the head of the last gives you 70 newtons. Here we've got some vectors in opposite directions. So this one is drawn the tail of the second to the head of the first, and we get the resultant going from here to here, which would be 10 newtons to the right. Now let's consider the boat going against the current. What does that look like? So here's our current going against us, so we draw the first one, then the second one, and the resultant goes from, let's draw it, from here to here. Now this is an example. What happens if we drew this one first? Well, if we drew this one first, it would go like this, and then we draw the second one. Let's change colours. Let's draw it actually on top, and so we draw that one, and then the resultant goes from the tail of the first to the head of the last. So we see that the resultant is exactly the same, even if we drew them in the opposite order. So don't get too hung up with the order that you draw them in. Okay, and our resultant would be 4 meters per second to the east, because it's pointing to the east. What happens when it's like this? Well, we should know that the crate's going to move off to the north. What's that? The northwest, isn't it? And so in terms of vectors, we draw one vector. In this case we drew the north one first, and then we put the west one there, and we draw our resultant from here to here, and we use Pythagoras to work out that that's going to be 141 newtons, and we get an angle which happens to be 45, so we can say north. Now if we'd drawn them in the opposite order, we still would have got exactly the same vector. Our triangle would have just looked a little bit different, but it was exactly the same in reality. It's just a different way of looking at the same triangle. What about here? We've got two forces, 100 newtons and 80 newtons. So here's our vector. Let's just have a go at drawing them in a different order, because I said we can draw them in a different order. So here they've drawn this one first and then this one second. So let's draw this one first, then put the tail of the second one onto the head of the first one, so that goes out like that, and our resultant goes from here, the tail of the first one, to the head of the second one. Okay, and you should see that that and that are the same line, and these triangles are just flipped over versions of exactly the same triangle. Hopefully we see that. Okay, so here we do the maths. This is Pythagoras. The hypotenuse is equal to the square of the hypotenuse is equal to the square of the sides, and so there's the square of our sides and there's the square root, so we get 128 newtons. We find this angle using, in this case, tan, but because we know three sides we could use sine or cos if you have a favourite one amongst them, and we get the angle 38.7 degrees. So we defined our vector quantity by a magnitude and a direction. Here's another example, two forces, and so what they've done here is they've used the terminology that you might have used in maths, where the hypotenuse is given the letter C and the angle opposite is given a capital C. So we have B and A, B and A, and so we've got C squared equals A squared plus B squared. Worked it out, 50C, so that might tie in with the maths that you're doing at the moment. And they've also used tan of B, so they're finding this angle here, and they found it to be 37 degrees. And they've given the answer as 50 newtons at an angle. Now they've given this as a bearing, and they're not using the 37 degrees, because the 37 degrees is actually this angle here. Now, when we give a bearing, if that's north and that's south, what we usually do to give a bearing, let's say in this case we're trying to describe this force here, so let's draw that out there, and let's change colours again. So this is north, and so we usually say whether it's north or south as our starting point, and our starting point here in this case is north. We're then told to move to the east, so that's going to be around this way, and we're told in the bearing to move 53 degrees. Whoops, 53 degrees, that's better. Now where did that 53 degrees come from? Well, if this is 37 degrees, if we draw that, of course that's going to be a right angle there, this is going to be 53 degrees, and that's the one that we're going to use as the bearing. So sometimes the angle you find in the triangle isn't then the angle that you use. What if we had south 53 degrees west. Where does that go? Well, we start off at south, we move 53 degrees towards the west, and so that's that direction. Got that? That's a quick lesson in bearings. Let's move on. Now, what about subtracting vectors? Well, we can use the tail-to-tail technique. Here we want to subtract A from B, or actually B from A. So, no, A from B, that's right. And so we join them tail to tail, and our resultant goes from there to there. Okay. Now, the only trouble with this technique is you're not always certain whether to draw from there to there or there to there. Okay? And so sometimes it's probably better to use this technique, which is the mathematically derived one, where we say that to subtract one vector from another, we do so by adding its negative. So what we're saying is, if we wanted to do A minus B, what we actually do is A plus minus B. Now, that equals the same as that, mathematically. If you're in doubt, add some numbers together on your calculator. So here's an example. Here we have delta V. Now, the formula for the change in velocity is the final velocity minus the initial velocity. So if because these are vector quantities and we want to subtract them, what we do is we add the negative. So we add minus u instead of u. What does that look like? Let's have a look at it. Here's an example. We're dropping a ball, hits the ball at 10 meters per second, so that's going to be our u. Rebounds upwards at 8 meters per second, so that's going to be our v. What is the change in velocity? We're assuming that down is negative. So here's our final velocity, point going up after the bounce. We're subtracting the downward velocity, which is 10 meters per second. So this is minus, so we need to add the negative of that. That becomes that. So if we put this one and this one head to tail, we would get this. And here they've done it mathematically as well. So they said the final velocity minus the initial velocity. Final velocity is 8. The initial velocity is minus 10. So they've actually introduced the direction sign there. And so the change in velocity is 8 minus 10. Okay, and you get 18. Yeah, I think that's right. And so now you should be able to do the force vector questions and the motion vector questions that you'll find on the OneNote. Cheerio.